The system behind me is the heat transfer training skid. It was built by students and it is a great tool for us to teach you about motor controls, instrumentation, fluid mechanics, thermodynamics, and how common energy system components are integrated together to make a process happen. Let's take a look at some of those components. This is the motor control center. It provides our control circuitry for the training skid. So our main power, which is 208 three-phase, comes into our primary disconnect. This disconnect is the on and off for the system. The 208 three-phase comes inside the motor control center, and we go into 3 fuses. Each of those fuses is protecting the hot. The 3-phase has 3 hots, A, B, and C. The fuses protect the branch circuitry. And then in this system we have an isolation transformer, so we can go and isolate. We have 208 3-phase on this side. We bring up 2 of the phases, and then down here we bring out 110 volt single phase AC. Then we have a 12 volt power supply and a 24 volt power supply. So this inside this enclosure there's 208 3-phase, 110 volt single phase, 12 volts DC, 24 volts DC. All those different voltages are required to run the different pieces of equipment on the training skid. Down here we have a motor starter, so we have the contactor and then the thermal overloads. Another contactor with thermal overloads. So these run our 2 motors that drive the pumps. This contactor that's right here that is actuating is our contactor for our heating element. So the heating element is being turned on and off right now to heat our heat transfer fluid. There is a sump pump to help fill the training skid, and then of course an emergency off button here in case we needed to turn all power off. On the other end of the skid is where we have our programmable logic controller. This is the brains of the skid. The programming code lives inside the processor, and here you can see that we have a network card. So we have a human-machine interface that we need to be able to communicate with an Ethernet cable. And then down here along this bus we have all of our instruments and control signals that come in and out through here. These are the different cards, and when we say cards, you can have digital or analog type cards that you add onto your PLC to be able to interface with your peripheral equipment. Here we have the human-machine interface, commonly referred to as the HMI. The HMI is the location where an operator or a user would interface with the system. So you can do set points, monitor system variables from the human-machine interface. You can kind of see that there's a pictorial representation of how the system is laid out. Because when you actually look at the physical system, it can be a little bit confusing, but this will lay it out nicely. So we have a tank, then we have a pump, a flow transmitter with flow indication, a flow control valve with control valve like the control variable indication. Over here we have, it comes up and we have a temperature indicator, a heat exchanger. Then we come on the other side of the heat exchanger and we have another temperature indicator here. And then we come out and we have another heat exchanger right here. So the way that this system works is that we have a process fluid. We go through this loop and we inject heat into the process fluid via that heat exchanger. Now since this is a training skid, we don't want that heat to continue to build up. So this tank water would just eventually get really hot. So this second heat exchanger is a heat extraction. So we have heat injection and then heat extraction. And we'll take a look at those heat exchangers here in just a second. This tank contains our heat transfer fluid. In this case, it's propylene glycol. There's a heating element in there that heats that fluid up. From there, when we heat the fluid up, it comes out. And again, we go through a flow transmitter that monitors flow. We have a flow control valve that is able to adjust the flow rate. We monitor the temperature of the heat transfer fluid. And we monitor the temperature of the heat transfer fluid as it exits the heat exchanger, and then it returns back. So in this system, in this loop here, we're constantly adding heat in here, and then we're transferring that thermal energy from the heat transfer fluid. We're transferring the thermal energy from here into the process fluid. And those two fluids never touch. They're not combined. They're going through what's called a plate heat exchanger. And then over here, we have other system parameters. So we have hot tank level, hot tank temp, process tank level, process tank temperature. And then here we can start the different pumps. Or here, like I was saying, there's two sets of fans on this heat exchanger over here. And so an operator could hit, and you can hear that fan kick on, or I could turn it off there. And so that's our heat extraction. Then we can go into our heat transfer, our hot controller. And in here we can set up for automatic mode, we can put it for manual mode, and we have what's called tuning constants across the top here. So these are our tuning constants. This is how the system would perform in automatic mode. So in an automated mode, we're using a PID, proportional integral derivative control scheme, and these are those parameters. And then if you want to run it in manual mode, you can actually set the flow rate, and you can see this is hot flow. Okay, and we can go to the same thing here. We can go into the process flow, so we can adjust the flow rate for the process loop. We can go into the heater control, and then this controls how hot are we trying to have that heat transfer fluid, so it'll adjust that as well. And we'll take a closer look at those parameters in future videos. It might be helpful to have your piping and instrument diagram and the ladder diagram set on the side while we trace out the system here. So let's start with the heat transfer tank. So this is the hot tank, tank A. Okay, so you can see that there's like a purplish color fluid. That's the propylene glycol in there. Okay, and right here we have a level switch here, a temperature switch, a thermocouple, another level switch, and then we have a tap right here. Now this tap is coming down and comes into this transmitter. This is the level transmitter. So this is a differential pressure transmitter that's been configured to measure level. So it's called pressure-based level measurement. Okay, and so the level controls, or these level switches, and this temperature switch are installed so we can ensure that there's the proper amount of fluid in the tank. There's a heating element in the bottom of this tank down here. If we didn't have heat transfer fluid in there, we could get the fluid could get too hot, and we could damage the heating element. We could damage the PVC. There's a number of things that could go wrong. So we have a temperature switch in here that acts as a safety, and then the switch is here. So that's part of your motor control scheme to ensure safety there. The thermocouple and the level transmitter are part of your process control. So that's a differentiation. So we have motor control that's controlling that heater cannot turn on unless this float switch is on, this float switch, and we've got an ample level, and we're below 140 degrees Fahrenheit. Okay, and then from out of here we've got a valve. We come into our motor, and this is a direct coupled centrifugal pump. And so we're going to come out of that system, and we come up over here. We come across, and we have a flow transmitter right here. So this is the flow transmitter for the hot tank A. And so this is monitoring how many gallons per minute. It could be configured for different units of measure, but that's what it's set up for right now. And then we come through this, and we come into a pneumatically actuated flow control valve. So this device sends a signal to the programmable logic controller. The programmable logic controller compares that measurement with the set point that we've set here and will adjust this while it's in automatic mode. If it's in manual mode, we as the operator are going to tell this valve where it should be in position. So we have an electrical signal that comes from the PLC, so that's this wire right here, and this is called an I to P, a current to pressure transducer, and it converts in from electrical signal to pneumatic signal, and it's going to move this valve up and down, thus varying the flow. And so you'll see this move, you'll see this measurement move. We come through here, and we come into the plate heat exchanger. This is an important concept here that plate heat exchangers, all heat exchangers, are passive components. You can't really adjust what the heat exchanger is doing. It's a passive component. What we can adjust is the flow rate through the heat exchanger. So that's usually. So we have a styrofoam insulation. We have one piece off so you can kind of see in there. We have styrofoam insulation, so the heat exchanger is not affected by the ambient air temperature. The thermocouple right here measuring temperature going in. And then we have another thermocouple measuring the temperature as it exits. And then we return to tank. Okay, so that was the heat transfer fluid, or the hot tank A. So tank B is our process fluid. Okay, so I guess in some cases this could maybe be milk or maybe oil or some other process. Some fluid that we're trying to control the temperature on. Again, in this tank, there's no heating element, so we don't really need as many motor control things. And also, all we really have here is we have one float switch, or a level switch right here. So there's this level switch right here, and essentially if the water drops below this point, then the pump would not work. So that's a motor control safety function. You'll see that in your ladder diagram, where if this float switch is not in a true position or closed, then you would not be able to run the motor. Again, we have instrumentation here, temperature and pressure base level measurement. So we come out of here, we have a valve. We come out into, again, your motor and your direct coupled centrifugal pump. From there we come across, and here we have a flow transmitter here. Okay, so this is a different type of flow transmitter. You can change this for different units of measure. We come through again the second pneumatically actuated flow control valve that again has an I to P on it. We come out and we connect into our heat exchanger. The temperature, the inlet temperature device is right here, so we're monitoring the inlet temperature of the heat exchanger, and then we come out of the heat exchanger right here to this other temperature element. Now right now the way it's configured for parallel flow. I'll get into what parallel flow is a little bit further along the way, but this is right now configured into parallel flow. And then these two fans here, there's one on the back here, one on this side. These are for heat extraction. Like I mentioned before, if we just continually added heat into this tank, it would get pretty warm pretty quickly and isn't very useful to us. So we're going to have a liquid to liquid heat exchanger here. So we're taking the thermal energy from the heat transfer fluid and injecting it into our process fluid. And then this is a liquid to air heat exchanger where we're extracting. So kind of seems counterproductive, but on a training skid, that's what you have to do. Otherwise, we'd always be trying to add ice or something in here to keep that temperature from going up. So here we have a couple, this kind of ties back here. We have temperature transmitters. These are temperature transmitters that are monitoring the temperature, giving us a local display. So you can see that we have local display, local display, local display, local display. But these are pressure transmitters. There's no screen down here, so the only place to read the level is actually back here on the HMI over here on the side. Okay, so that's the rundown of the system, and we'll kind of start taking a look at each piece and component even a little further in detail.